Saxon Advanced Mathematics. Hi students, we're here today to talk about the unit circle. This form that I sent to you is helpful for a starting place, but you could easily make this. I've done it before with students where we just put a small plate on the paper and trace around it for the circle, and then the lines that are in here you can easily put in yourself. So if you ever want to make one of these and you don't have the form handy, just get a circle on there and go from there. Okay, what I want to do is first orient you to the fact that this is basically a circle imposed on a grid. You don't have to do this on yours. I'm going to do some drawing on mine that you don't have to copy. I'm just helping you see things. Notice that this is a y-axis and this is an x-axis. Let this be my work copy, and then I have another copy that I will make just the way I want you to copy yours, okay? So this is kind of my worksheet. Okay, so what we see here is that we have our usual x and y axis, or as we've been calling it sometimes, this is the right axis and this is the up axis. But there it is, right? And then this circle has a unit of 1. The radius of this circle is 1 all the way around. Thus, the name unit circle, okay? Now, the first thing that what we're gonna do is we're gonna gather a bunch of information that we already know and have talked about, and we're going to organize it on here. The first thing I want to do is talk about our old friend, the 45, 45, 90 triangle, right? It's 45 degrees, and the sides are 1, 1, square root of 2. So we can easily find that the cosine of 45 degrees is, let's see, that's adjacent over hypotenuse, so that's 1 over square root of 2. And the sine of 45 degrees is the same number, right? Excuse me, because both of these sides are 1. So the opposite is also 1 over square root of 2. Now we've got irrational numbers in the bottom. We don't like that, so we're going to multiply both of them, top and bottom, by square root of 2. And what we'll get is something that looks like this, right? We've done that a million times. That's familiar. We also know that there's a positive and negative business here, right? We've seen this a million times. Okay, so this is going to be useful in just a second too. What we want to do is go to our triangle. Now this is where you can draw along with me. We can see that right here, and I would like you to trace this. If you've got different colored pens handy, that's ideal. Do you see how right there at that line, that's exactly halfway through this quadrant? So this must be our 45-degree angle, right? So I'm going to write that. Let's put that about halfway along that line, 45 degrees, okay? At this 45-degree angle, this point we know, because we figured it out right here, we know that at this point we have a cosine. Cosine's always associated with x and sine is associated with y, you know that. The point here is square root of 2 over 2, square root of 2 over 2. We think of that as the point here. I'm going to rotate my paper just a little bit so I can write as if this were a straight line. Now this I want you to put on your page, over here maybe somewhere by where it says unit circle. Cosine and sine, like so. What that tells you is that this notation here gives you the cosine and the sine of 45 degrees. Oh, you don't have to draw that triangle now every time you want it. It's right there for you. Now we can do the same thing in the other quadrants. This angle is 45 plus 90, right? So this is 135 degrees. This point is also has a cosine of square root of 2 over 2 and 2, right? It's got the same values, but in the second quadrant, sine is positive, cosine is negative. So we want to reflect that. And what did I just say? I said in the second quadrant, sine is positive, cosine is negative. So it would be negative square root of 2 over 2. Right? This tells me that at 135 degrees, cosine is negative square root of 2 over 2, and sine is positive square root of 2 over 2. All right, we're making progress. Now we'll go to the third quadrant and find that same angle. Now let's see, what is it? It's 180 plus 45, so this is 225 degrees. Again, we know that these are the values of sine and cosine are the same. We just have to check out the positive negative signs. In the third quadrant, sine and cosine are both negative. Negative square root of 2 over 2, negative square root of 2 over 2. Don't worry if this isn't perfectly neat. This is why I had you print 6 copies of it, because I know you're going to want to write this over and over. A, to memorize it, and B, to get it looking really cute. Okay, so we have third quadrant, and then we have fourth quadrant as well. If we take 225 and add 90, that's another way to get this total. This is 315. And again, 315 degrees. And again, the sine and the cosine are going to be square root of 2 over 2. We know that. But in the fourth quadrant, let's see, sine is negative, cosine is positive. So it's square root of 2 over 2, negative square root of 2 over 2. Okay? So now, if we can glance at our unit circle, we've got the sine and cosine in opposite order, cosine and sine, of all the 45-degree triangles in all 4 quadrants with the positive minuses all sorted out for us. Yay, we don't have to draw that triangle anymore. We can just reference by looking right here, and it's all sorted out for us. Okay, I was just looking for the cap for my pen because I'm going to switch to a different color. Okay, we did that one in red. Now let's remember another triangle. This is the third, oh, sorry. I'm busy writing away off camera. Here's another triangle that we know. Notice that I've switched colors because now we're going to talk about this 30-degree triangle. That's got sides of, let's see, this is the 2, this is the 1, and this is the square root of 3, right? This is the original line. This is the one that was chopped in half. That's the one that we have to figure. So we know that for every 30-degree angle, the cosine, which we always list first, is the adjacent over the hypotenuse. So that's square root of 3 over 2. And the sine, which is the opposite over the hypotenuse, is 1/2. So for every 30-degree angle in each quadrant, all the way around, just like we did for the 45s, we're going to use these values for cosine and sine. We'll have to straighten out our plus and minuses using this chart, but we'll do that as we go around. So I'm using a different color now, and I'm identifying the 30-degree angles. There's the first one, 30 degrees. And this, we said the value is square root of 3 over 2, 1/2. Both positive in the first quadrant. All right, let's go to the second quadrant. That's the angle we want. Ooh, got a little wobbly there. Let's see, that one is 90 plus 60, that leaves 30 here. So this is a 150 degree angle. And we know that our values are going to be square root of 3 over 2 and 1/2. But what about the signs? So we come over here, and actually we don't even have to look at this. We know in the second quadrant, we know cosine's negative, sine is positive. But look, we've already established that pattern here. So we don't have to keep checking back there. We know that in this quadrant, all of our values are going to be minus on the cosine and plus on the sine. Okay? Let's go to the third quadrant. Now we have to be careful here because we don't want to confuse our 30, and as you've probably figured out, this is going to be our 60 degree angle. We're measuring from this axis, so this is the guy we like for our 30 degree work, and that is 210, right? Because it's 80 plus the 30. Again, we can follow our pattern of plus and minuses here. We've already established it, and we know those are our values, so it's minus square root of 3 over 2 minus 1 over 2. Okay? And then the fourth quadrant, it'll be this one, 30 degrees down from the x-axis. And that will be, let's see, it'll be 270 plus another 60 is 330. And again, we use our same numeric values for sine and cosine, and we follow this pattern of plus and minuses. So positive and negative. Okay? And what I'm going to do, I'm double checking these as I write them, but I'm going to send you a copy. Let me just show you. I've got this over to the side that I'm just double checking my values on to make sure I got it right. I'm going to send you guys a copy of this too, although I might do a better one because like this one, some of the minus signs are really hard to read. Like that does not look like a minus sign, but it should be. So I may find another version of this and send it to you. But I will send you the answer so you can double, triple check that you're copying the right thing. Okay, so now we've put in all of our 30 degree angles. So you probably can guess what's next. We're going to reorient this. Ooh, that was crooked. So that we're looking at our 60 degree angle. And on this one, let's see, this is the 2 and this is the 1. And this is the square root of 3. So for this, the pair of points, the cosine is adjacent over hypotenuse, and the sine is square root of 3 over 2. Notice that this pair of points is the opposite of this pair of points, and that's because the 30 and the 60 degree triangle are based on the same overall triangle, right? They're just swapping definition of what's opposite and what's adjacent. So that's why those values are the same. They should be the same. Okay, so now we're going back into our circle and we're looking for the 60 degree marks in each quadrant. So here's the first one. And I can write 60 degrees. And now you can see that if you were trying to make one of these without the pre-printed grid, you would just, let me just do this so you can see it better. You would just eyeball those 3 lines. You could draw those in yourself, right? Put in the 45 degree first, and then go a little bit up and a little bit down, and then recreate that in each of the 3 quadrants. And you could do this without having the pre-printed form. This just makes it a little bit easier so we can focus on the numbers instead of drawing pretty. But you could do it on your own. Okay, so at 60 degrees, we just figured out that cosine first always, is 1 over 2. Sine is square root of 3 over 2. They're both positive because we're in the first quadrant. We know that. Okay. Now here's the 60 degree guy in this quadrant. Let's see, that's 90 plus another 30. So that's 120 degrees. And cosine is negative here. So it's negative now we're in the third quadrant. It's this one. Let's see, that would be 180 plus another 60. So that would be 240. And again, we know our numeric values. They're the opposite of this, but everything's negative in this quadrant. Right? And then fourth quadrant, here we are. And this is 270 plus another 30. So this is 300 degrees. And cosine is positive, sine is negative. Okay. So now what we have done is we have taken all three of our special triangles and we've laid them onto this diagram showing all four quadrants, and then we've calculated sine and cosine and put the correct positive and negative signs on each of those values and attached them out here so that in a heartbeat we can find sine and cosine of any one of these 12 angles very easily. Okay, now we're ready to add the next piece of information. Wait right here, it's in the other room. Pause, take a sip of your beverage, stare out the window for a sec. Okay, I'm back. The next piece of information we're going to add are these, dear friends, the quadrantal angles. Okay, we've already got all the information we need. We're just going to put it onto the unit circle. We know that at 0 degrees, cosine is 1, sine is 0. So I'm just going to copy that right onto here. Cosine goes first. Cosine is 1, sine is 0. And this is 0 degrees, okay? Sometimes we also write 360 degrees. You can use a fourth color for this, and I don't hate that I put that green in there, so I guess you can write that if you want. Okay, so there's the first one. Now let's go up here. This one, I'm gonna write it like this, 90 degrees, right? At 90 degrees, cosine is 0 and sine is 1. So we write them in that order. We write 0 and 1. Okay, now we're over here to 180 degrees. At 180 degrees, cosine is minus 1 and sine is 0. Minus 1 and 0. And then down here at 200 that's 180, this is 270. At 270 degrees, this is 0 and minus 1. And there it is, 270, 0 and minus 1. Okay. I want to tell you something about quadrantal angles separate from the unit circle, but now is a really good time for me to share this. I don't think I've shared it in the regular lesson. I'm going to draw for you a sinusoid. Okay, you can draw along with me if you like. This is not going to go directly onto our unit circles, but it's super cool. Okay, here's our sinusoid. We have a center line of 0 and an amplitude of 1. So this is just a basic guy. And we're going to draw the first period of a sine curve. So this is 90, 180, 270, and 360. Okay? Sine comes out of the 0 position. It goes up, down, and then it goes all the way down at 270 and back up, right? Remember, this is 1 and minus 1. So now I'm going to draw this in. Okay, now let's look at the pattern of what happens to the value of our curve. At 0 degrees, it's at 0. At 90 degrees, it's at 1. It's all the way at the top, right? At 180 degrees, it's back at 0. At 270, it's at -1. And at 360, it's back at 0 again. Now, compare this information to what I have written for our quadrantal value. This is a sine curve. Okay? Sine, 0 degrees, it's 0. 90 degrees, it's 1. 180 degrees is 0. 270 is -1. The sinusoid draws us a picture of these exact same quadrantal angles that we've been talking about that confuse everyone and make not that much sense. The sinusoid curves illustrate exactly how these quadrantal values behave. That for me is a huge help. This to me, just writing them down, that's really arbitrary. I don't get that really. It's just numbers I memorize. But when I see this sine curve, and I understand where the 1 and the -1 are coming from and how these 4 quadrants each have these values, suddenly it all fits together for me. And when we have, let me flip this up. When we put those values on here, I see that what we're kind of doing is we're kind of picking this up. Can you imagine if you could pick this up? Imagine it was like one of those wiki sticks or something that's bendable but still stiff. If we took this and kind of twisted it here at one, no, we have to flip the whole thing over, but we could make this shape go into a circle, couldn't we? We could bend this into a circle. I guess the easiest thing to do would be to take the top half and bring it over so it was like this, right? And then we squinched it. It would be a circle that would go 0 degrees, 90 degrees, 180, 270, and we would have the exact pattern that these quadrantal angles are giving us. So all of this fits together and is related. And so when you're filling in the sine values for these quadrantal angles, you can just think of the sinusoid curve. At 0 degrees, it's at 0. It goes up to the top, it goes back to the middle line, and then it goes down to -1. Isn't that cool? It all fits together. And then, of course, when we're talking about the quadrantal angles and we want to talk about cosine, we have same but different, right? Here are our 4 angles. This is 0 degrees, so this is 90, 180, 270, and then back to 360, which is the same as 0. Cosine starts at the top, right? And it's really easy to remember these when we're talking about the sinusoids because for whatever reason, our brain remembers shapes much more readily than it remembers just numbers in a chart without context, right? This is a picture that is very easy for me to remember, and I think you too. Okay, so let's make sure that this works just as well as we think it does. All right, I'm just gonna scoot this up a little. We don't need to see sine at the moment. With cosine, it starts at the top, 1. At 90 degrees, it goes back to 0. Then it goes down to -1, and then it goes back up to 0. And then at 360, it's starting over again. And that's why we say 0 degrees and 360 degrees are the same. All right, so the same pattern holds for this. The sinusoid draws us a picture of how these values are behaving, and we can copy them onto here, but we can also figure out cosine straight from the sinusoid looking at this. It starts at 1, it goes down to 0, it dips to -1, and then it's back up to 0 and ready to start at 1 again. So now we've connected our sinusoid curves to this chart. I mean, do you not have goosebumps? It's so cool how everything fits together. Now, there's only one more piece of information that we want to add to this chart, and that is that we want to give the measure of all of these angles in radians. The reason we want to do that is because if we can see that radians and degrees are the same and we lay the pictures next to each other, we can start connecting in our minds radians and degrees much more readily. Right now it's kind of like, oh, we have to do this big calculation. It's kind of a pain. But once we start seeing how they sit with our other friends, they're going to seem a lot less annoying and gross. So what I'm going to do is I'm going to start at 0 degrees. And I'm going to keep switching my colors back and forth so that I'm writing the radians in the same color as all the rest of the information on that row. 0 degrees is 0 radians. Oh, that's really fun to remember, right? 30 degrees. Now, what's the rule for how we calculate radians? Here, I'll use this piece of paper. 30 degrees. We multiply it by pi over 180. That's how we translate all of these, right? So 30 degrees multiplied by this unit multiplier, we've got degrees on the bottom. 30 into 80 goes 6 times, so we get pi over 6, okay? And what color? Oh, it is red, okay. So this is pi over 6. And I'm writing it sort of as a squishy fraction so that I can fit it in. All right. Okay. That is pi over 6. Now let's do the 45. Oh, I did it wrong. That was supposed to be orange. Oh, I'm so sad. Oh, well. 45 degrees times pi over 180, not equals. This goes into this 4 times, so that's pi over 4, right? And then the 60 degrees, times pi over 180 degrees equals pi over 3. So I turn this pi over 3, okay? Now, we've put these radian values next to the degree values, and as your brain sees them together, it will start to connect them in your memory, all right? Now, here's a cool thing. As we go around, all the relatives of all the 30-degree triangles in the different quadrants, all of their radians are going to have a denominator of 6. Oh, interesting, right? They all match. All of the 45-degree cousins will have a denominator of 4, and all of the 60-degree angles will have a radians measure with a denominator of 3. That pattern will hold up, and it's super easy to remember, right? Because the 6s and the 3s are opposites. It's not 30 degrees and 3 on the bottom. It's 30 degrees and 6 on the bottom, 60 degrees and 3 on the bottom. So they're mixed up, but that's easy to remember. And then 45 goes with the 4. Oh my gosh, perfect, right? So easy to memorize. Now, what I'm going to do is I'm not going to calculate every single one of these because you know how to do that. You just multiply the degrees by pi over 180, okay? And cancel. That's all there is to it. What I'm going to do is write the answers in, and I want you to look at the patterns as you copy them. Okay, so when we're in the second quadrant, up here at the quadrantal angle, this is pi over 2. Pi equals 180 degrees, so that means 90 degrees would be pi over 2. Okay, now we're in the second quadrant, I'm sorry, getting excited. And this is 2 pi over 3. This is 3 pi over 4. And this is, sorry, I need my red. No, I need my orange, sorry. 150 is okay, so here we go again. This is the angle that relates to the 30 degrees. It's over 6. This is the one that's related to the 45. It's over 4. This is the one related to the 60. It's over 3. So our rule holds out. And now look at what the numerators are doing in this quadrant. Each numerator is 1 less than the denominator, right? 2 is 1 less than 3, 3 is 1 less than 4, 5 is 1 less than 6. That's gonna make it really easy to memorize these 3 radians values so that you can fill this chart out really fast without having to think too hard. You don't have to do all those individual calculations, right? Okay. That's gonna make it a lot easier. And so we're gonna look for those patterns in the radians as we go. Now we're all the way around to 180, and that is pi. We know that, right? Because we've been saying it all along. Pi, this is a unit multiplier, right? So pi and 180 are equal to each other. All right, cool. Now we go to the third quadrant. Again, this is the 30 degrees, so we know it's gonna have 6 on the bottom. And it is 7 over 6 pi. And 225 is, oh, I'm sorry. I shouldn't have written it like that. I don't like how I wrote it. Write it like this. 5 pi over 4. Let me just fix this one. 7 pi over 6. Okay? You can also write it as 7 over 6 pi. That's what I was kind of doing in my head, right? I wrote it like this. But that's confusing because that looks like it could be 7 over 6 pi. That's not what we mean. This is what we mean, but this is too confusing of a notation. So better to write 7 pi over 6 like that, all right? This is kind of like the equivalent of a mixed number. I was trying to set that to the side, but I don't like that. Do this. This is the better. Okay? So I fixed that. Okay. And then we've got that one. I'm messing up with my orange and my red markers. Forgive me. And then this one, this is the 60-degree angle. So it's going to have 3 on the bottom. It's 4 pi over 3. Now let's look at the pattern in this quadrant. The pattern in this quadrant, we still have our 3 for the 60 degree, 4 for the 45, 6 for the 30 degree. But now look, our numerators are now 1 greater than the denominator. In the second quarter, they're smaller. In the third quarter, they're larger, each by 1. Okay. Now we're at 270. We're halfway between pi and what we know is going to be 2 pi. So this is 1.5 pi, which we write as 3 pi over 2. It's getting dangerously close to my 270. Okay. And now we're ready for our fourth quarter. And I'll give you those. Again, this is the 60 degree, so this is going to be over 3. This is 5 pi over 3. And the red one, that's our 45, so it's going to be over 4. 7 pi over 4. And our orange one is 11 pi over 6. And then just as long as we're here, let's go ahead and do 2 pi is equal to 360. All right. Now let's look at the pattern for the fourth quadrant and see what we can remember. 5, okay, if we took the denominator and doubled it, it would be 6. This is 1 less. If we took the denominator and doubled it, it would be 8. This is 1 less. If we took the denominator and doubled it, it would be 12. This is 1 less. So what we can see is that if you can memorize the denominators that go with each radian measure of the degrees, there are really strong patterns in each quadrant that help you memorize the numerators. Of course, in the first quadrant, the only numerator is pi, or 1, I guess you should say. But these are the basic ones because all we have is a denominator. Then here, the denominator is 1 less, or the numerator is 1 less than the denominator. Here it's 1 more, and here it's 1 less than double. Super easy to memorize that pattern. So this, you guys, is our unit circle. It has so much information organized onto it. And so the question then students often want to know is, how do we use it for a problem? Well, let's look at a problem that we did in lesson 65. I taught it to you last night. It was this trig equation. We were talking about the radicals, and we agreed that this one doesn't give us any drama whatsoever. And we found out that the tangent of x was square root of 3, and the sine of x was minus 1. Well, we had to stop and think and draw pictures. But if we just take this one, for example, sine of x is minus 1, then we can look at our unit circle and go around and go, okay, sine is the second number. Where is that equal to minus 1? Oh, there's positive 1, but we want minus 1. So I'm just going around and I'm running my finger all of these. Sine is the second one, right? So I'm going around looking for, there it is. I have to turn my head, but there it is. There's the minus 1, 270 degrees. So there's 270 degrees. And remember, we ruled it out later because tangent is undefined at 270, blah, blah, blah. We had drama with that. But I found that the sine of minus 1 was 270 degrees just by skimming my eye along in the sine position until I came to that value right there, okay? That's how we can use it in actual problems, is it just pulls all the information together and gives us one quick place to look at all of these different triangles and values and sinusoids, radian calculations. All of it is just here in one place. And what I'm gonna have you do, and this is the reason why I had you print out 6 of them, I want you to practice remaking this, drawing it again and again in whatever patterns make sense for you. You can follow the same order that I put things in, right? 45 degrees, then the 30 degrees, then the 60. You can do it that way, or you can do it in a different order. You can fill in all of the first quadrant, then all of the second quadrant. You can do it however you want. I do really recommend the colors because it helps you see the patterns between the different angles. But have fun with it. Do it different ways. We will, maybe not this week. I think I'm going to probably do it next week. We'll probably use this as our review problem. I will have you fill in one of these for your review problem. So go ahead and play with that and practice doing these. If you sit down before you do your homework and create one of these, you don't have to write any of these triangles in your homework, right? Once you've got this memorized, you can use it as a reference and you don't have to make a note of it. On the test, what I'll do if I decide I want to use this, I would give you one of these blank forms and ask you to fill it out at the beginning, and then you can use it in the test without having to show your work. So it's super useful, but we do need to memorize it. But you already know all of this and can easily calculate it. So that's the situation. If you're wildly confused, reach out to me right away. If you're moderately confused, talk to me about this in the video chat. If you're right on top of this and feel super comfortable, then high fives to you. If you don't get it now, you'll get it soon, I'm sure, because you're understanding all the pieces that go into this. So yeah, that's our friend, the unit circle, and he is gonna help us out big time. Thank you for listening. I'll talk to you soon. Goodbye.